Thank you. You know what they're talking about downstairs, Aaron? What? AI. Fuck. I don't know about that currently, but that's a lot of AI everywhere. It's not just your track.
Nope.
Alrighty, we'll go ahead and get started. So my goal is to talk about what we've learned using LLMs on pen tests. This isn't really a AI hype talk. It's not an AI doom talk. It's just kind of in between and just kind of realistically how at least I see it today. So as Aaron mentioned, I'm Alex Lauerman. Founded a Pentesting company called Trust Boundary. I founded BSidesKC, and I like hacking stuff. Lots of building tooling, automation. So this using AI is right up my alley. I'm really enjoying it and taking it as fast as I can. Okay, so just kind of the thing we're all wondering, especially if you're hearing some of this hype, there's all this autonomous AI pen testing hype, mythos. GPT 5.5. There's always just crazy new models coming out all the time. They're always getting better. It's just, there's tons of great models and tons of marketing around them. And they are finding like really cool bugs, or at least kind of cool bugs, real 0 days, really impressive bugs, such as like the 23-year-old FreeBSD 0 day that Mythos found recently. And so there is some validation behind all the hype for sure. And then we'll talk about kind of what actually works today. What's on real engagements, on real targets, what we see. Okay, so we'll talk about kind of where it helps, where it fails, the patterns that work, and the real moat, and we'll end up with Q&A. So we'll start with the wins, just basically all the good stuff that AI does. So code reviews, it does amazing at. Has a huge context window. It can look at tons and tons of code. The coding agents have kind of invented the way of sorting through the code base and figuring out what code is relevant. They follow that and been able to produce a lot of really good context for the LLM, which produces good bugs. It catches lots of weird esoteric stuff that a human might not normally see. I think we might be low on battery in this one. Lots of bypasses, post message handlers, just weird JavaScript things like that are. They're around still?
No.
You see another mic around here somewhere?
He took it with him. I thought he had it to hack with.
All right. I'm okay to keep talking, but I don't think it'll be recorded. But okay, I'll keep going. Where are we here? So finds all sorts of crazy weird stuff. It's sometimes really hard for a human to see. Often very hard for a human to see. It also is great at writing code, which provides a lot of new attack surface. Usually code's pretty good, but there's definitely bugs in the code that's written. So there's just lots of new stuff to do, apps, new stuff to attack. In Anthropic's research, which is based on code review, they found like 500 bugs using Opus 4.6. I don't think these are all validated, but it's just potential bugs at least. And in the Mythos I mentioned earlier, they found a 23-year-old FreeBSD bug, really impressive, really hard operating system. So the key here is, and also the screenshot there is showing like how simple the prompt was that they used to find those bugs. This isn't like fancy, complicated, crazy stuff. This is just you're playing in CTF, find a vulnerability, write the most serious one to report.txt. So super simple prompts, running that in a loop over a bunch of files. It doesn't take a ton of crazy prompting and orchestration for that to work. So the bottleneck, as I mentioned, is more around is not just finding the bugs, but it's actually validating them. I mentioned those are 500 Opus bugs that Opus found, but they're not all validated. Maybe 400 of those are valid, maybe 50 were valid. It's just there's a lot of work to do after the let's find something. So AI is good at recon, broad coverage, like sorting through huge, 15 megabyte JavaScript files, exploitation assistance, payload generation, format conversion. There's lots of super helpful things that it's good at. Yeah, that'd be this one. But batteries are out of it. Sorry. It's all fixed. We've tried a lot of AI testing tools. There's tons of stuff on GitHub, tons of tools on for everything, including pen testing. We haven't found one that really shines. They're all just good at different things. But the plug code is just being having agentic harness is really helpful in our favorite way to do things. You kind of customize it, kind of do whatever you want. I guess that's what Anthropic, very smart researchers from Anthropic are doing it that way. So it must be if very smart AI researchers are doing something simple. We don't need to do something extremely complex to find those. Right.
Wow.
Where'd you take that thing?
I was getting scavenger hunt items. It is down there. I told you, just walk that way and yell scavenger hunt.
You started it. Cool. So where were we here? So we like Cloud Code a lot, or Codex or any of those. Just kind of agentic, flexible interfaces are great. The way you configure them is also you can have an MCP, hook up different tools. I mean, just the sky's the limit on what you want to do. You can hook up different sub agents, configure them in different way, any way you want, just depending on what you want to optimize for. I think generally just making sure they're very thorough is a challenge. The newer models, especially Opus 4.7, tends to be a little lazy from what I've seen. Tends to kind of think that it's solved problems and they're still in progress. So just kind of have to encourage it to be really thorough. Here's an example of just a simple skill, just an example skill running pen testing, finding pen testing findings. You probably can't see that from there, but it's really easy just to write skills randomly, just ask Claude what you want it to do, and it will find potential bugs. Validation is another step, but it will find lots of potential stuff to look into, which is great. The AI can be super helpful with reporting and just kind of all the boring stuff that goes into pen testing. This is probably really boring if you're not a pen tester or have never been a pen tester, but it's probably super exciting if you have been. Just all the reporting monotony is really tedious. There's tons of boilerplate text that we're constantly writing, tons of little formatting errors, tons of things that you're just customizing depending on what TLS cipher suite's in use or something that just is super tedious. It's hard to make that all consistent across the team and customize. AI helps a lot with that. The other thing is here's an example here, which is going to be too small for you to see, but sending it up to our reporting pen testing platform, you can just use AI to document these things and as well as review human written output or machine output to help improve it. So AI is super helpful in just the entire back-end process. I think that's the biggest win for us, is just making everything as efficient as possible. The things that it really excels at. Let's see. It also helps write code. So if you're writing tooling like this, you can just get further faster than ever, and that's a great thing. What's shown here is just AI PR, just reviewing report content, suggesting improvements for a human to review and go through and decide how to make the report as good as possible. The irony is, I'm not sure how much this will continue to matter. It's always been a pride of every pen tester to write reports as cleanly as possible and make things as thorough and detailed or reproducible as possible. But I'm not sure how many of our customers are just throwing things in the Claude code and saying, fix this, and not even reading it. So if that's the case, it probably doesn't need to be super clear, but our goal is to make it as clear as possible for the time being. But I'm not sure exactly. I think that stack between pen test report, Jira ticket, months in the queue, and then being code deployment is just going to get thinner over time. I'm not exactly sure what piece of that is going to be eliminated. Yep, Jim.
Have you thought about basically generating a prompt or how do you use it?
Yeah, the question, just to repeat the mic, is have you thought about generating a prompt for customers to use? Yeah, we have an API that agents can communicate with. My goal is to make it as agent and human friendly as possible. but it's mostly focused on humans right now. But I think that's, I don't know how many of our customers would want that, but I'm going to guess more the cutting edge and bleeding edge startups would. But our current focus, I think a lot of people just copy and paste stuff and throw it into Claude, which is fine. But yeah, you can do everything at scale and just say, fix all the bugs in this report if you want to be kind of lazy about it and see what let it rip through everything. So yeah, there's an API that facilitates that. And yeah, it's I think making things agent friendly is definitely important. Another thing is, this is kind of related to just being able to write code. It enables a ton of data analysis. So just being able to get crazy analytics and stuff like that we've never been able to get before is possible. I think it's kind of ridiculous. Pen testers are probably some of the worst at this, but I'm sure a lot of other professions have this too, where it's just really hard to answer how many cross-site scripting findings do we identify last year? How many, what bug class do we see the most of or the biggest increase of? Just questions like that have been really hard to answer over a bunch of different engagements. And now we can kind of collect and analyze that data in a nice way. And I like that. I think those trends and analysis and stuff is just, I don't know, super useful, very helpful. So another place that, I guess the first thing that we saw where AI was really good at pen testing was CTFs. They're nice, confined problems with a clear win situation. There's no blast radius. There's no concerns about production servers or anything like that. And they're usually like moderately hard problems that are solvable within a reasonable time frame. So AI does really well at those and continues to do better and better. I think it's solving like a lot of CTF problems, but not some of the hard and really hard ones. It just kind of depends on the model and the problem. But anyway, CTFs kind of came first, and that was the first place that we saw them doing really well. And then they've gotten better and better at different tasks since then. So now we're seeing that a year or so ago we started hearing kind of that they were more applicable on like could be used for pen testing, and then now we're just seeing everybody using them across the board for finding bugs. So we'll talk a little bit about where AI fails. The one place we've seen it fail, and this is my personal failure, is being confused. It's just the attack surface is weird. This is the only slide about testing AI, not testing with AI, but I think it's a story that I think of for this. So I was testing an LLM chatbot, and I convinced it to give me, I'd been chatting with it for a while, and I finally convinced it to do bad things, and I got like Etsy shadow out of it and all this stuff. But what I didn't realize is I was communicating with, it was just hallucinating the whole time and just tricking me, and it was making up everything that I asked for in some reasonable format. And it had me fooled, and I thought I found something cool, but I didn't, and I'm still a little embarrassed about it. So I mentioned earlier about just it's easy to generate tons and tons of bugs, and Ryan talked about this with his first talk about kind of bug bounty programs and that their challenge there. This in this chart, you can see just the number of bugs and open source projects going through the roof. Some of those are true positives. Actually, probably all those are true positives, but the false positives are going to be even higher just because it's so easy to find potential bugs and that look seemingly valid. And this is, again, just a problem for even the smartest researchers at Anthropic. They can find tons of bugs. They just he had 500 bugs, say, sorted by severity. He picked the top one, and it was severe, but it didn't have time to go through the rest at the time of his presentation, or at least many of them. So it's just the human bottleneck is real. Also on like, there's a lot of cool bugs and research coming out, but the false positive rates are never published. It's just on their OpenBSD bug. They mentioned Mythos found the FreeBSD, I think, bug 3 out of 10 times, which is like an okay rate, I guess. I mean, it's better than 0 out of 10, but it's hard to know. You really need a human in there to kind of validate whether that's true, because if it's only exploitable, if 7 out of 10 times it says it's secure and not exploitable, that seems like a believable case, but that isn't there once a human types in and actually tries to exploit it. So, and token cost is real. I mean, they spent quite a bit of tokens on it, but the human cost is larger, I would guess. They didn't publish the human cost, but they have a really talented team working on this stuff, and they spent $20,000 of tokens, but I'm gonna guess the human time would be a lot higher than that they put into this research. So yeah, validation is a huge challenge, even for the best models, the best researchers, and that will continue to be the problem for at least the near future. So another challenge is with hallucinations and issues with severity. So it will make an issue look like a real issue, and it's is like really convincing that it's a real issue, but it's not, and you really just have to go in there and analyze it and figure out what the case is. You can use a really good validation pipeline to minimize that as much as possible, but the farther you take things with automation, the more false negatives you might be throwing away and false positives you might be including, I guess. You're gonna have to go in one direction or the other. So it's a challenge to get perfect, great validation as automated as far as possible. And there's lots of issues with severity. AI is like so good at certain things, but it's really struggles with interpreting severity. It thinks everything's critical, and you can kind of convince it otherwise, but it's just, and put a lot of standards around it, but it's still just as really hard at interpreting specific situations and whether they matter or not. When agents meet the real world, there's let's see, they can they either don't know when to, they can run into problems where they don't know when to stop. They keep looking at a target that's down or something like that, or wasting tokens on a bad path. There's just also concerns around, are they really going to interpret the guardrails that I put in about rate limiting and things like that? So it's just hard to know exactly what AI won't do all the time, although it's, with good prompting, you should be able to limit that quite a bit. It's just hard to know for sure. I would say humans have the same challenge. Like, you can ask a human, don't, run a nmap with over, or port scan with over this rate or something like that. And there's limitation on that. Humans may not follow those instructions either. So, there are, there could be prompt injection issues where they are following instructions from the target and they get confused. Agents just do weird things sometimes. So patterns that work, I think this is changing. I think this is kind of what I've came to, conclusion I came to here. The big variables I see are the prompt, the model, the token usage, the orchestration, and the tools involved. A few years ago, I would say orchestration was a huge part of this. You had to really work hard to get good vulnerabilities out of GPT-3 or something like that. It was not agentic and not very smart compared to today's models. And things have changed. Models are really good. And with the prompting, with some decent prompting to kind of create some orchestration around that, they're super powerful. Orchestration is getting less and less important, or at least it's super easy. I guess it's important, it's just easy. Claude Code just does that for you. It just does what you ask it to do without any fancy coding on the back end. Token usage, I think is balancing that is a challenge, but just keeping it high, getting good coverage on everything is a priority, and the token cost is relatively minimal at the time being. So it's to at least find a lot of potential bugs. And the tools, I have them as a smallest variable there today. If you change out like a certain tool, you're using Playwright instead of Chrome MCP or something like that, you're going to see different bugs and how they're configured. So just all these small changes will yield different bugs, and that's actually kind of something that humans would run into as well. You ask 3 different pen testers to look at the same attack surface, they're going to find different things. It's just a little bit more visible with a LLM when you're getting just different sets of bugs out with different configurations. So it's the same problem we've always had, but or same challenge we've always had, but it's just a little hard to know what tool set is going to be best for on a certain target. So there's definitely challenges there on the tooling side. and just minimizing, balancing coverage with token use, and just there's tons of variables there in play to try to maximize coverage with the time you have. And Claude code just came out like less than a year ago. I mean, things have changed so much since then. And agentic models came out around, I guess, February. I think, just a little over a year ago. So it's or thinking models actually. So things are changing quickly. What was hard a few years ago is now quite a lot easier. So all this orchestration, everything, writing the code, any code on the back end, is just you can move a lot faster, a lot more quickly now. So I guess the takeaways are AI is finding bugs faster than ever. Validation is the new bottleneck. The moat has moved. Expertise is where it lives. This is kind of tying in a little bit overlap with Ryan's talk earlier, that you still just need a lot of human expertise to either finely tune these models and with a lot of validation to get them as far as possible, but additionally perform human validation if you want to get like 100% accuracy on these. So there's definitely a place for a human element within finding bugs still. I think one evidence or a piece of evidence of this is like the LLM or the HackerOne leaderboards, the various bug bounty leaderboards. They're all humans at the top. There's not people that are. I mean, they're using AI to help them along the way. But if someone let's say there's $1 billion of unfound bugs in bug bounty programs. If someone had something that would just print valid bugs with 100% accuracy, they could just kill it and make hundreds of millions of dollars. But the fact that nobody's able to really just dominate shows that there's just a lot of those small tweaks to variables that matter a lot, and a lot of human validation that takes time. Once we see someone just killing it with tons of valid bugs, that might change. I think that's it. Any my contact information is there? Any questions?